Is correct. And then,
So a couple quick questions. So for those of you who have gone out and checked out some of the content, just kind of a key point, the folder that you want to go to is the 125L folder right on, if you look up here, right on the main F drive there. If you go to F, Department ME, there's a folder called Valley, and there's a lot of similar content there. But the one for the class is the one that's regularly maintained, and that's kind of true of most of these folders. If you go back in here, you see all these classes there. If you're taking some of those classes, those are normally the folders you're going to look into. A lot of people do about the same thing, so I follow suit. So. Are there any questions before I start into the lecture?
The homework for the C group, man.
Eric is working on it, so
It's going to be a lot.
It might be a little while. And whenever you happen to get it, it will be you'll have it. I think for the homework that went out, I think I gave a little over a week, or at least a week for everybody, so it'll be similar. Any other questions? All right, so I'm gonna look quick at the syllabus just to update everybody so you know where we're at. So tomorrow, starting tomorrow, you'll go to your normal lab time. So like everybody, A's, B's, C's, everybody meets this week, whatever times you meet this week. And for the C's, you go back to, you don't meet you go back to your normal lab time, whatever was on your web advisor. And you'll see why. All we're going to do this week is we'll probably collect the homework for those who have them. I think it was due this week, wasn't it? We'll collect the homeworks, and then we'll separate you into groups, and then you can start working in your group as a on your group project. And also, it's really valuable. How many people have worked on a group project at the School of Mines already? So it's a smattering, good. And for those of you that haven't, your study group, maybe this is just a little bit of a general comment, is this, the people that your study group that you develop here at the School of Mines is really valuable. That's one of the ways that you can be successful in college, is to have good social networking with fellow students. And it's nice and deliberate that we have a project in the freshman year so that you can get to know some people that might be helpful to you. And these projects are the way we assign them, these two, is designed to do that. So what you're going to do is talk about your group project, also get to know the other folks in your group, and if you have a weakness that you're concerned about, like how many people really feel really strong about SolidWorks? Good. Now those of you who don't feel strong about SolidWorks, you want to know who those other people are, because SolidWorks learns pretty quickly, but it's nice to ask a few questions. And the same is true of everything we're going to talk about. So that's what this week is all about, is getting those groups assigned. So then next week we'll go back to lab, and Group A meets next week, and then so BC have the week off for lab, but then the following week the converse is true, that A has the week off and BC meet, and then we go into spring break, and then we'll repeat A, B again after that. And we'll have a lecture here on dimensioning, and then we have a guest lecture the following week from CAP. Now, it's been a really good lecture in the past, so the dimensioning lecture, which I will deliver next week, is very specific to how your different options on dimensioning, explaining a little bit about GD&T, will really get you a good start on your project. Ryan will have a dimensioning lecture later that talks more specifically about GD&T, and also a lot of the pitfalls that he's seeing. He's been doing this much longer than I, and he's seen the sort of problems that students have with their dimensioning and building. So that's kind of what we got to look forward to in the next few weeks. Any questions about the syllabus?
Are the group projects going to be assigned? Or are we going to end up arguing with each other or what to do?
Yeah, you will end up arguing with each other about what to do, and that's part of the success of the project is working with other folks. So, good point. I am not going to tell you what to do. And I think that's good. I think that works out for everybody. Any other questions? Okay, well enough. We will start on our group on the project assignment. Okay, so the individual project, now here is for the so for the virtual design option, basically and these projects are all new, so we don't this whole design the virtual design option is all brand new. In fact, it's so new that we just changed the name of it today. We previously called it graphic design. We decided that's not appropriate, so now it's virtual design, because it's only a little part of it is graphic design. But so within these different 4 different lab options, we're expecting a project out of one of those. You only have to do one of these, you don't have to do all 3. So you have your option of doing 3D printing something. You can pick something that you want to 3D print, and I'll give you some examples later. And then for that, you have to come up with a fully dimensioned and tolerance SolidWorks print, and then a request for work, which is specific to 3D print. And if you decide to go down that path, then you'll work with Jimmy or Ryan as to what it means to define that part for them. Now, with 3D prints, one of the reasons you might 3D print something is you have a lot of flexibility in shapes. And you can imagine, say, a boat propeller would be relatively easy to print, right? Hard to machine, but also very difficult to dimension. Things that tend to be things that can be easily machined are also normally easily dimensioned. 3D print stuff doesn't work like that. And we have methods for dimensioning those that Basically, if you go down that path, we'll talk about it, but I'm not going to go into it. But just know that that's what's required. That's what you will be graded on. If you design something and you go to print it, it doesn't print very well, or you don't get it done, that's acceptable. But your grade will be based upon what you turn in terms of paper. Is there any ideas of why I might grade this class that way? Because you'll find that that happens. It isn't true of all your build classes, but this is kind of a project class, but you won't be graded on what you build. Is there a reason why that makes sense in this class? Does anybody get over?
Doesn't always line up with the real world.
No. Let me stew on that one a little bit.
It would just have to do with the fact that it's just a class and we're still learning all this.
Not quite. There is some truth to that because now sophomore you'll turn right around and you will be graded on the project and the results. So that is true, but why did I specifically in this class say, I am going to grade you on print and work orders?
Because it's getting us introduced to the process, working with the team, putting in the right work orders, and trying to accomplish a project rather than of our project details.
Exactly. You guys are all want to be engineers, right? And that's how you're going to make your money. You're going to make your money on the prints and work orders. Which, what do engineers produce? We produce paper with information on it. So that's why we grade here. And everything else we're doing here, you know, like when we're working in the shop, we're gaining knowledge that allows us to better produce that paper. Make sense? And that's really easy to understand with the DFM side, the virtual design side. With the 3D print, it absolutely applies. If you do the CNC stuff, it absolutely applies. With the graphic design and marketing, that's more the upper level management teamwork stuff. Okay, so good answers. If you choose the graphic design, you have the option of a 2D logo or a T-shirt design, and then product detail with a 2D or 3D rendering, 3D animation of a product with SolidWorks. You'll be closely working with Eric on any one of those options, and Eric will grade that in its entirety. Kind of the same with the 3D print stuff. I don't really grade that stuff. I turn it right over to Jimmy and he grades it. Or Ryan.
So if we pick graphic design, we'll have to do all three of those.
You pick one of these three. And with the marketing, contrasting case study of a successful product and an unsuccessful product. Those, John and or Lisa will help to grade, probably John. Lisa's going out on maternity leave. Okay, so that stuff's all new. This is exactly what we did last semester, if anybody's heard about last semester. So for the individual project section design, individual project section, design for manufacturing, fully dimensioned and tolerant SolidWorks print, a complete work order, and calculated feeds and speeds showing your work, which is exactly the homework you're doing right now. Anyway, so I really hope by the end of this class, I'm not going to say that calculating feeds and speeds is paramount to engineering, but it is kind of good to understand that. It is paramount to doing projects here at the School of Mines. It's great to catch you guys as freshmen before you start doing your sophomore, junior, and senior projects, because I've seen so many mistakes in this area. That's why I kind of beat this horse to death. So that's part of that project. Anyway, and we'll get some examples here in a second. The group project. You're going to see a lot of repeats here. Fully dimensioned and tolerant SolidWorks prints, a complete work order or work orders, calculated feeds and speeds. With that, what I want to see on the individual and the group, I really need to see one example that demonstrates that you have the capability to do it. If you're like, so I just gave you in your homework, you did 2 tools. To be honest, if you do one for your project, that's fine, and show that you can do it and do it correctly. Because you might have a project, especially maybe you have a project where you have 20 tools. Well, if you were going to build that, you would need to calculate all those, but I don't need to see all of them. Okay, a 3 to 5 minute video selling product or reviewing project as marketing tool for attending SDS&T or ME125L. The point here is I want to see a project, a video. How many people have put together a video before? Yes, no. I'm not looking for like, if you want to use your phone to create the video, that's fine. And if you want to use Windows Movie Maker, how many people have used Windows Movie Maker? It's really easy to use, or however you want to do it. What's that?
It's also not a default install.
Oh, on campus?
Yeah.
It's not,
Yeah, you're gonna have to get that one. It's a great program.
but it is available on campus.
Yes, I have it.
So the key is we only, and maybe we'll talk about this when we separate into groups, you really only need one person in your group that kind of knows how to do this. And just to tell you, demonstrate how easy it is, even I can do it, and I'm 47 years old. So
Or you come in a film club and you can do.
yeah, and there's a film club that would be happy to help. So what I'm looking for here is conceptualizing of the marketing ideas that you guys were given in that presentation. And granted, only some of you were given that, but that's the way these projects work. There's going to be people in your group who are given that information and others who don't. So anyway, and that's intended to be kind of fun. And part of the reason I started this is, well, maybe I'll talk a second about the 3 to 5 minute presentation outlining the project, process, issues, and learning. So what you're going to do is just in your lab groups, which there's going to be 3 to 4 groups per lab group, that at the end of the semester you're going to get up and present. This is what we did, this is why we chose it, this is what we learned, this is what the mistakes we made, and this is what we liked, this is what we didn't like, whatever. And so basically the video is going to be real similar to that, but with both of these we'd like to start bringing in some of these marketing concepts. Now I give you a couple of people that things you might want to market. You know, this is our project, and this was great for me, and this is a great reason to go to the School of Mines. Okay, you don't have to do that. Or you can say this is great, this project was wonderful, and I learned so much. This is why ME125L is such a great course. Or something completely different. Just, try to bring some of what you have learned in there. Now, okay, so why I did that, when I went through, we've been doing these presentations for a while, and what often happens is we go through these presentations and I'm like, wow, that was awesome. That is exactly what we were going for here. I would love to show this to the ME125L students next semester, but short of having all of you come to that class, I can't repeat that presentation. I could just record it, but I thought, no, it would have a fun new element to this class, also bring in some of the marketing, and it creates that record for me that I can then use for a lot of different purposes. Now, why do I say, let's bring in the SDS and selling for SDS&T? To be honest, this project, how many people, how do I ask this question? You all considered other colleges before you came here, right? How many people looked at the projects on campus and said, hey, those are kind of cool, that's something I might want? That's real common here, right? Well, so short of coming to campus and seeing that stuff, we have no way of getting that out to future students. I intend to use this information for them, because we get contacted by high schools and all these, can you send out a contingent to speak with us? Sometimes we can, sometimes we can't. CTE in Sioux Falls, they're always asking for us to work. Well, this would be nice if we could just send these videos and say, hey, this is one thing that our students are doing. So you see the value there? So that's why I mentioned that. That doesn't mean you have to do it. Maybe you don't like the School of Mines and you hate this class, then those would not be good approaches for you to take on this video. But I want it to be fun, and I want to capture that moment in time. And so with that in mind, I almost eliminated the presentation. And in fact, there was a group, did anybody, and we'll look at it, there was a group last semester, everybody hear about the snowmobile spindle group? They had a really cool project. And I said, wow, I'm impressed, guys, nice job. And then I said, I want you guys to make me a video, because I want to show that next semester. They said, yeah, no problem. They came in and they taped it, and I haven't got it yet, but you'll probably see that eventually. And I explained to him, I said, I'm going to take the video and replace the presentation. Well, one of the guys in the group has been out working for CAT for a number of years. He said, don't do that. He said, those presentations can be really rough as freshmen, but they're important. They need to get used to doing that because you get out to work. He's working at CAT every day, right? So he knows that he's doing presentations every week. You just got to get used to it. You know, just the presentations we do in here, we expect them to be perfect, right? But whatever they happen to be, you're going to get some experience on it. That's all we're looking for. So that's why we kept them both, and they may be very similar. Then there was a last request is that we just do a design fair, and that's how many people have been at the senior design fair? Okay. Well, you'll hopefully go next semester. Well, the design fair is just where we'll set you up on tables. So we're going to have 20 groups in there, whatever it boils down to. You're each going to have your projects there. You're going to do a poster, bringing in some of these newly learned graphic design concepts and marketing concepts. So a poster, you have a video plan on your PC, and you're just standing there talking about whatever's left of your project, maybe your prints laying out there. And the main intent, to be honest, to that is just, there's a lot of value in it as an engineer. But to me, I think it's going to be really good because one of the things I was kind of bummed about last semester is we had neat projects and a lot of real similar projects. But if you were on Thursday and this guy was on Tuesday, you never saw that. So this will be a chance for you guys to kind of walk around, see what everybody else is doing. So, and you can see the last three things there are all about presentation, all about being comfortable in front of people and marketing yourself. Other than that, the project is very similar than the individual project. I do expect, I talk about this. I'll talk a little bit more about that. So basically what you're actually going to do as a project is going to be identical to your individual, except for there's 5 of you, roughly, and you have more time. So I guess what I expect and I have seen is that the quality and volume of work from the individual project goes up with the group project. And you might do that by incorporating. I discourage people from including Mastercam in their individual project. But I'd say we had about 1/3 of the groups that included in their group project. Anybody know what Mastercam is? It's a CNC software. So if you want to run the Haas or the CNC lathe, or you want to run CNC, and I'll give you examples of people that did. It's a great tool to learn here, and we'll give you a really brief review of it in this class in a few months, and then you'll enter in a month. And then you can, if you want to run with that, it's graphical, it learns pretty quick, and you just make a choice to go down that path with your project, and then we'll help you through that. Ryan's probably our best expert, Garrett's awesome, Chandler, Spencer's getting good, I'm learning. CNC, I've got a lot of experience with, Mastercam not so much, but we'll help you through that, and it's been a good learning experience. So that's one way. Another way is just to use an assembly. I won't accept assemblies on the individual project. Assembly being like the birdhouse as opposed to the steel piece, right? The birdhouse had 6 pieces, so you could do an assembly. An assembly works out real nice as an individual, as a group project. The other way is just to do something a little more elaborate. Maybe you did something really simple for your individual project, and then as you get together as a group, you do something a little more elaborate. Which brings up, maybe when I get to the examples, I'll kind of go back through this. Okay, so the reference materials, ME 110, how many people have been through 110, or either are in 110 or will be? How many have it? There's 1. For 2. For the only thing you're missing out there is the SolidWorks intro. And those, basically, in 110, I think they still do it the same way. They have some tutorials you go through, right? So we'll give you, if you want those tutorials, you go through those tutorials and you'll be caught up. The other thing you can do is just open it up, start playing with it. And that's part of the reason why we have 5 people in your group. There, obviously, unless we put you 2 and find 3 others that don't have SolidWorks experience, there's going to be people in your groups that have SolidWorks experience. So that's good in that, and maybe either way, you're going to find that a couple of your people in your group end up doing most of the SolidWorks, and that's fine. Well, the collaborative effort here is on the design and the concepting and the problem solving. You might have, not everybody has to run SolidWorks on your group project. However, on your individual, everybody has to, because you have to turn in a SolidWorks print. So that's why this is all assigned at the same time. Ask those people, ask us, me, Chandler, Spencer, we're all good at it, and we'll help you. So that's what you get out of 110. The template for the work order, I'll show you that in a second. SolidWorks and and then the examples from the labs. You know, like if you did the birdhouse, you can pull up those prints and look at them as an example of what you might want to follow. Same with the work orders. And then the MCO and Toolmex online catalogs, that was what you used for the homework you just did, right? So that's all reference material that's available. Okay, so the grading, accuracy, and completeness of drawing, work order speeds and feeds, and I mean that is what I mean that is exactly what I mean. Those prints have to be fully dimensioned. Every feature must be dimensioned and tolerance. The title block has to be complete. And to that end, I encourage people, particularly on your individual project, to choose a simple subject.
I was going to ask, can you do rough drafts prior to the official hand date?
And have me look at it?
Right.
Absolutely.
In ME 110, sometimes you miss a quick dimension, which is simple but missable.
And what you'll see, Kate, after, and we're done with lab in like another month, right? And then we have the rest of the semester, which is a couple more months. We will meet in during your lab time every week. I will be there, and you guys will meet and work on your group and individual projects. And during that time, I'm going to answer any and all questions. You want, it's like, you got it done, you want me to look at it, I'll look at it, and I'll tell you what's missing. So yeah, absolutely. But like I said, it has to be accurate. And when I was working at Caterpillar, that's what I did, is I looked over all the other engineers' work and I told them what they did wrong. I'm very good at finding things wrong with prints, missing dimensions, material, call-outs, title block information. So, I grade all those. And if it's missing, I'm going to check it wrong. So and the point to this is that I want people to get the process down, to understand the process with a simple print, a simple part, and then as you go to more elaborate parts, next year you got to turn right around to software design. Your project's going to be more elaborate. But if you got this process down, believe me, it will save you a lot of trouble. So that's a big part. So then I want you to consider the build method, and that's in the work order there where you plan what you're going to do. I want you to kind of think through that and come up with, incorporate those ideas that you learned in your labs. Then just the quality of work, the material selection. And again, the reason this is a big deal, I'm going to expect you to find your materials on either Online Metals or McMaster-Carr, or if you want to go to Pacific Steel locally. But the key is that before you put something on that print, I want you to find it somewhere and know that it's available. What happens with incredible frequency, it's gotten a lot better since we started doing this, is people walk into the shop, they go, hey, I want to build this, here's my print, and they normally didn't have any material written down, and they'll say something like, I'll say, well, what's your material? They'll say, oh, any old aluminum. Okay, that's one big mistake. Another big mistake would be to say, well, I want this out of 7075 T6 because I looked it up in the back of machine design, and that's the best material that I can get. Or maybe they have a welded part out of 7075, come back to welding. And then they, and I'll look it up and I'm like, well, the part you have there, you cannot get that stock in that material. And it's kind of a problem here, or it has been, But the reason I'm kind of a stickler for it is I've seen that in industry. And unfortunately, you know, if it weren't for a class like this, which is a freshman class, you go through machine design, when, hell, you guys haven't had, some of you probably have had machine design. And that's where you're going to learn how to pick materials and this and that. You're going to pick them for material properties. You're going to look up in the back of the book and it's like, yeah, I'm going to buy this. Well, if those materials aren't available, and to be honest, a lot of those materials are only available in limited sizes and quantities, or maybe no longer available at all, and you put that on a print, then you send that out to an outside supplier, I'm talking when you're an engineer, then now all of a sudden your job has a big problem. And that's why so basically here, whatever you put down there has to be available and reasonable. And we'll ask you to look up the price, and that's one way of forcing you to look into those catalogs. We mentioned welding again. Like 7075 isn't weldable, and that used to happen very often is that students would bring in something that was 7075 and they want it, and they got a weld spec. It's like, well, it's not a weldable material. Okay, that's not that big a deal. So there's an easy example. You're going to learn about conditions, and particularly in aluminum. T6 is the most common one. It's a precipitation hardened material. So 6061 T6 is a precipitation hardened material. 6061 type O is an annealed material with no hardening. The relative strength of those two materials is roughly 3 times. Meaning T6 is roughly 3 times stronger than type O. So what happens if you take a 6061 T6, which is weldable, and weld? What's the strength at that weld?
It goes back out of the condition.
That's exactly right. And you see that a lot. And so, in fact, we just saw with the rocket team, not picking on those guys because I could, but last year, and I said, okay, it's a red flag to me. You spec out a precipitation hardened material, then you want it welded. You realize that your strength at the weld is going to drop. So you probably spec that material for a reason, right? You wanted that strength. So I asked them, well, why did you pick this material? What kind of analysis do you do? They did everything right. They did all the right strength analysis. So then my next question is, what was your factor of safety? Oh, my factor of safety was 2, which in a lot of cases, that's pretty good, right? Factor of safety means it's twice as strong. Whatever the applied stress is half what the material strength is. So factor of safety 2. Well, I said, okay, so you've designed this part to fail at the weld. Is that what you really want? Which is what they did, because they would have needed more than 3 to accommodate the annealed condition. Well, no, and in fact, this was a rocket. What would do if it failed there? It would explode. So that's why, and that's a student example. I have another example. When I was in industry, I was designing stuff for a nuclear power plant in Japan, and I received a T6 condition. It wouldn't have to be T6, but it was a precipitation hardened material that had a weld on it. So I immediately fired an email back and said, you know, this is a problem that you have this weld on this precipitation hardened material. There are other problems. Anyway, long story short, they said, no, we know what we're doing, don't bother us. So I saved that email. We went about building the part after a good deal of trouble. And what do you suppose happened to this? And this was a cooling tower. It was about a 3-foot diameter